Okay, so my name is André, and honestly, I'm really surprised. Many of you are here probably for the whole day. One moment. And you can't get enough about machine learning, I guess, right? So that's why you are still here. Okay, so my name is André Netzeband. I'm software and machine learning engineer or AI engineer nowadays at the Volkswagen Data Lab. However, today I'm not going to talk about a professional project. I'm talking about a private project, which is talking agents. And this is an agent which creates podcasts out of research papers. First, I want to describe the motivation for this project, then the 70% approach, which I started with. Then I will describe the requirements engineering I did, or which requirements I collected. And then I will go into technical details. And for the 20 minutes, I cannot describe everything, but I wanted to describe something which is the most important, I would say. This is the question and the answer preparation in order to get a good quality out of the question and answers. In the end, I want to share my learnings with you, and then we hopefully have also some time for questions. And the mic is going away. So, okay. Now let's start. I think for software engineering and AI engineering, continuous learning is absolute key. So you have to do it, and reading research papers is one essential part of doing that. However, reading the papers takes a lot of time, and the worst thing about it, it's screen time. So you can't do anything else in the same time. And instead of reading the papers, I was asking myself if I can't not just listen to the papers, for example, in a podcast. Then, for example, I could cook in the meanwhile or cleaning up my flat. And when I have a very interesting paper, I can still follow up by reading it. So the question was for me, why can't there be a podcast for every research paper out there? And since there is not a podcast like this so far, the question was also, can I use AI to do that? I started with a project in October 2024, and when I was finished after around 3 months, there have been 5 other projects which also solved this problem in the meanwhile, which is on the first view, it was a little bit depressing for me, but since it's a private project and I don't earn my money with it, it was okay. I still learned a little bit, and I want to share my learnings with you today. Okay, I started with a 70% approach, and it worked very well. So I was just uploading a research paper to ChatGPT, and then I was asking to create a podcast out of this. And I must say the result was already quite good. It was a very lightweight podcast style. It also got the core message of the paper, which is important, of course. And it also gave very good explanations. However, it is really just a 70% solution because the questions have been very superficial. The answers are too short, leading to a too short podcast for only 5 minutes or so, something around. And every generation, the output format looked a little bit different, which made it very hard to transform it into some text-to-speech, so into audio files. And it was also hard for me to check it for hallucinations, and the guest and the host didn't have any kind of personality. So, and I was thinking, well, the 70% solution took me just 5 minutes, so the 100% solution is then a 10-minute solution, a 10-minute thing. And this is a pitfall I noticed a lot in my daily business at Volkswagen, where I work with business units. And all the POs at the business units, they have access to ChatGPT, and they just upload their data there, try out something there, and then they come to me and say, hey, we tried it already out with ChatGPT. It's working perfect. We only need this and this and this and this and this. And I guess you can finish it within 1 week because you are IT, right? So you can do it very fast. But this is not true. Actually, to reach the first 70% takes 5 minutes, but then to reach 90%, for example, you might need weeks or months, or maybe when it's going to production and must be super robust, you are even talking about maybe 1 or 2 years in a project. And the problem is that the business units are often not understanding this. You first have to explain it to them. Well, okay, I was aware of this, of course. So when I was thinking about how I can improve it, I was first thinking about So how is a podcast in reality? So when we humans do podcast, how is a podcast actually produced? Does anyone has experience with producing podcasts? Can you tell me, how do you produce a podcast? This is one important part of it. Absolutely. Okay, an expert. So I was just once a guest in a podcast. What I noticed is you of course have in the beginning a preparation step, where normally the host and the guest having a short talk without recording it. They're discussing the topics they want to discuss during the podcast. They're also discussing possible answers, follow-up questions, and maybe transitions from one topic to another topic. And probably both are taking notes, so that the host is not forgetting the questions and that the guest is maybe preparing some technical details for the podcast episode. Afterwards, there's a second step, which is the interview itself. And here the podcast is actually recorded. The host is then asking the prepared questions, and the guest is then answering the prepared answers, I would say. And the third step is now the post-processing. This is exactly what you told there. This is applying audio filters, mixing in music, creating the different output formats, creating the teaser text, and uploading it to the different platforms. So, and a business person would now say, well, this is a business process. This is a business process of creating podcasts. And actually, my experience with a business from Volkswagen is that many business processes are look like this. Maybe sometimes you have 4 steps or 5 steps, or sometimes you have a loop or maybe a condition inside. But more or less, every business process looks like that. However, as a software engineer, when I look at this, I say this is a state machine. And this is exactly how I implemented it in the end. I implemented a state machine out of it. And every step in this business process is a node in the state machine. And I have also sub-state machines in order to have these sub-steps. For example, for the preparation, we had different sub-steps. And the important thing is why many state machines in software engineering are actually event-driven. This state machine I implemented here is completely data-driven. That means that the data is defining the transition from one state to another state, which has a very, very nice advantage. Since the data is stored after every state to a persistent memory, for example, a database or to the local files, you can just interrupt the processing at any step. Then you can, as a human, look at the data. You can try to understand what the AI is currently doing there. You can change the data, and then you can just continue the processing. And since it's data-driven, it will continue the processing at exactly the step where you have been interrupted it before. So this works very well. And after doing this with this project, I found out that for many similar projects with Agent, I'm always better by having state-driven state machines, data-driven state machines. Here I was using LangChain and LangGraph. LangGraph is kind of useful, I would say. LangChain also, but it has a very confusing API, as most of you know who have already used it. It has a lot of legacy. I don't want to blame them because they have been the first out there which did all those things. But it can be a little bit a pain in the ass, I would say. So nowadays for recent projects, I use more Agentic AI, and also I substituted LangGraph with a custom graph framework, which has this data-driven state machine property already built in. Okay, so I now want to describe one certain step of the preparation, which is gathering or the creation of the questions and the answers, and to ensuring a high quality of the answers. So in the preparation step, I first read in the PDF, and then I start to chunk the PDF and store it into a vector storage. I have also a second vector storage, which I call example storage. So it is going over the chunks. It is trying to get examples out of the paper and then storing them in a dedicated vector storage. This helps in the end to get more examples in the podcast content. And then I create a list of the topics from the paper. And after I have the list of the topics, I create for every topic questions and answers. And the answers are given here in the preparation step as bullet points because it makes it easier to work with it and also to review them as a human if I want to do that. And later during the interview step, the questions are actually then I do something like a style transfer of the bullet point answers into the real podcast answers. Okay, now have a look how the questions are created. So as I said, I have this list of topics. It's an iterative process where I just take one topic from it. I start with the first topic, and then I create a question out of the topic. It's simple LMM call. Afterwards, I give this question to a second node, which is the answer question node, and this is giving out the bullet points. And here it's just a single node, but actually there is a whole state machine behind, which I will describe on the follow-up slides. But for now, just assume this is a black box. You give an answer in, and you get the bullet points, you get the question in, and you get the bullet points answers out. But together with the bullet point answers, you also get some KPIs, some quality KPIs. One is if the answer is complete, the groundedness score and the redundancy score. I will also describe the scores later in more detail, what they mean and how they are calculated. But I do now a quality check and say the answer must always be complete. It's a yes or no. And the groundedness score must be above 70%, and the redundancy score must be below 50%. And when one of those conditions are not fulfilled, I'm not happy with the quality. And then I give the question back to an adapt question node, which is then looking to change the question in order to get a better answer for it. So, and then it is giving this question back to the answering question node and doing the quality check again. In case all these quality criteria are passed, then I give it to a follow-up question node, which is then just checking if there are follow-up questions from these answers. And if this is the case, it is always giving it back to the answering question node, and then we have the quality check again. It can also make the decision that there are no follow-up questions, and then it's just taking the next topic until the list of topics is exceeded. Okay, now we will have a look into the answer question node, which is quite complicated. So the first thing I did here is that I rephrase the question. And this was necessary because the question from the podcast host is often very casual. And the paper has a very technical language, technical vocabulary. So I found out by rephrasing the question into a more technical question by using the summary of the paper, I can get better results with the regulator because the vocabulary is a matching. The next step is that I give it to a node, which is actually a reg solution, where it answers the question at bullet point with the help of the vector storage as a standard reg solution. And then I have another reg solution, which is now looking for examples in the example storage, which can be added to those answers. Afterwards, I do the first quality check, which is a groundedness evaluation. And here I use the LMM as a judge. So the LMM has here the task to decide if a statement given in the answer is actually grounded on the source. And the source are the selected chunks from those both vector storages. And if the statement is grounded on the source, I say it's grounded. If not, then it's ungrounded. And the score is calculated by the ratio between the grounded statements and all the statements. And if now is a score below 70%, I give it back to another node, which is now adapting the answer. It either skips certain points of the answer which are not grounded, or it tries to find evidence in the vector storage, example storage, or by internet search in order to find the source for those statements. With this, I try to avoid hallucinations or that the LMM is using knowledge from their training, but not the knowledge from the paper. Okay, I do this maximum 3 times because my assumption is if it doesn't come up with a grounded answer within 3 attempts, then probably the question is a little bit off, and then the question needs to be adapted. Then we are in the author loop where the question is adapted. The next step is, when I pass this step, is a completeness evaluation. Just assume a question can have, for example, 2 parts. And then you get the answer for both parts, but the answers for the part 2 are then maybe discarded through the groundedness evaluation. Then probably you will get for the podcast a very, very strange answer where the host is asking actually 2 questions and you only answer 1 question. This is very strange. So I have this completeness check, which is also using an LMM as a judge. And it checks if the answer is really answering both parts of the question. And when this is not the case, it is formulating a follow-up question, and then it goes all these checks again until it reaches there. And the last check I do here is the redundancy check. For the redundancy check, I also use LMM as a judge, and here the task is to check which statements of this answer have already been in the answers of the questions before. And then the score is calculated by saying this is a ratio between the characters of the redundant statements to the characters of all statements. And here I do not use an adaptation loop because my assumption is if the answer is too redundant to the answers before, then probably the question was already redundant, and then actually the question needs to be changed. Okay, this is about how this works with the question and the answering gathering. Now I want to share some learnings I have from this project. So the first learning I had here was that LMMs are always better for small and for more focused tasks. So every node in the state machine should really just focus on a single responsibility, on a single task, I would say. And when you have 2 complex tasks and you are not happy with the performance, try to split it up into more simpler tasks. So one example is here, for example, the groundedness, completeness, and the redundancy evaluation, where I tried to do this first in a single step, but I found out it is not working very well. It was always very confused, and then I split it up into 3 steps, and suddenly it worked very well. The next thing is, it's not surprising, the rack quality is very essential for this kind of projects, which means if you have a rack insight, there are so many decisions you have to do for a rack. You have to decide about the chunking algorithm, the chunking size. You have to decide about the retrieval algorithms and maybe a re-ranker and all those things. So it's really worth to evaluate the rack by yourself, to ensure that the rack is working to an optimum before you embed it into a more complex project. Because even if you have all these things like groundedness evaluation, redundancy evaluation, when the rack is off, then you are just iterating over those steps, but it cannot find a good answer. It cannot find a grounded answer, for example. Then the next learning here is that if you have projects like this, you should really use tools like Langsmith and Langfuse. I don't know if ZenML has it also, something like that. Ah, okay, I see. Yeah. So those tools give you the opportunity to help with debugging. Give you the opportunity to help you very well with debugging because you see the internal transitions of your state machine. You can see the internal states, the intermediate data, and you can see all the LMM calls. And then you can directly see, okay, this answer, for example, was not grounded. That's why it tries to do it again. And then it gets this result. And it helps a lot doing debugging. However, all these tools are always coming with some kind of prompt versioning, and I was really surprised how bad this works with these tools. In the end, I was settled down for using Jinja 2 templates. These are they are very, very helpful. And then just having the prompts together with the source code inside the repository, which also has the advantage when you change the prompt together with the source code. Normally you change both together, then you have it in a single pull request with a single review, and both are not getting off from each other. Okay, that was it from my side. Thanks for your attention. Try out the repository. Everything is open source. You will also find some example podcasts there, and I'm also happy to connect with you via LinkedIn. Do you have any questions?
There is an internet search that is supposed to help groundedness. I don't understand how internet search can help increase groundedness.
I found out that especially for papers which are very famous, for example, the attention is all you need paper, right? So every LMM is nowadays trained on those paper texts. So it is often taking knowledge from the training over the knowledge from the paper itself. So I was just giving an additional source in order to gather additional information when it's coming up with some statement. Because some statements are not actually inside the paper, but you have a lot of blog articles where those things are then explained. And when it can find it within a blog article, for example, then I say, okay, now I'm happy. But I understand there's a certain threat with it. So it's just a private project. It's just a fun project. If I would implement something like this for a business unit, then probably we cannot rely on internet search. I completely understand your concern. Yeah.
Have you tested single parts?
Thank you. Have you tested single parts of your whole pipeline with, for example, length views evals or something similar?
I didn't use length views evals. I have some half automatic test benches implemented for that, especially for the rack, where I excluded it from the whole project, and then I was just looking how the rack behaves with different algorithms. But yes, length views has a very nice feature for that, and I would highly recommend this for using it. Yeah.
For that to use, you will probably also use prompt versioning in length views, because then you would want to know which evals ran with which prompt and which version of the prompt.
Yeah.
But this is like more advanced.
These are the trade-offs you have to make, right?
Of course, because I feel you with prompt management and variable management in prompts. This is probably way easier if the prompt is in the code and you can use Splinter for that.
Yeah.
So, but the space is still evolving. Maybe we have something that merges both in a few years.
Yeah, I really hope so.
Thank you.
Thanks. How are you evaluating the quality of how RAG is working?
So I was taking one example. As I said, it's a private project. So in the professional world, I do it more professionally, I would say. But here I was just taking one example paper, which I already knew very well. And then I was looking at the questions which has been generated and tried to find the answers by myself. And then I was using similarity search and also LMM in order to map the answers I would come with the answers it has been extracted from the rack.
Okay, thanks.
The state machine would be a better solution than an agent just running on its own. Maybe can this imitation of current state of LLMs, or is it?
That's a very, very interesting question. I have thought a lot about this. So actually, when I started the project, I was also thinking, oh, now I just have an agent which will find out how to do a podcast, something like that. However, it was not so successful, honestly. And over time, I was thinking differently about that. I think many business processes are very well described. And just assume that a new employee is coming to a company. And you would not give the employee a task and say, just do it. We don't care how you do it. Actually, when a new employee is coming to a company and is doing a business process, like, for example, in the HR or in the legal department or so, this person will be trained on the actual business processes. There will be someone who is saying, look, you have to take this data and then you have to compare it with this data. Then you store everything here. So on a very high level, the processes are actually very well defined in the same way how actually a podcast creation process is more or less defined, that you have these 3 steps: the preparation, the interview, and the post-processing. And you actually don't need an LLM to find out this for every single call, for every single podcast, because when you already have found out how to create a good podcast, then you can just reuse this process all the time. And I think this is a very rigid solution, I completely say, because everything is hard-coded. The whole business process of podcast creation is hard-coded in Python code. It's very hard to change, and it's also very hard to adapt to new requirements. But I think in the end, we will come up in the agent world with something intermediate. We will have business processes which are described on a high level. We have technical details which are described in a technical way with Python scripts or what else, right? And then we will have agents which are looking at the actual requirements we have, which business processes are in the business database, and then it will either take one of those business processes or adapt one of the process which is there available in order to adapt it to the new requirements. I think this is maybe the way we are going towards.
Sorry, I think we need to get going to the final speaker. Is it possible that you could
we will follow up later.
follow up?
Good. Thank you.
All right.